Hello students, let us try to solve some more problems on equation of line. Okay, let us start. The first question says, show that the lines x plus 1 upon minus 10 equals to y plus 3 upon minus 1 equals to z minus 4 upon 1 and x plus 10 upon minus 1 equal to y plus 1 upon minus 3 equal to z minus 1 upon 1 intersect and find the coordinates of point of intersection. So we need to show that lines intersect, students. Let us start. Let us consider the first line equals to lambda, and from this we get x is equal to minus 10 lambda minus 1, y is equal to minus lambda minus 3 and z is equal to lambda plus 4. So we took the first line and we assumed it as lambda, so we get xyz. But this xyz is a variable point, students. Therefore, we say the coordinates of any point on this line are xyz, which is minus 10 lambda minus 1, minus lambda minus 3, lambda plus 4. Let us call this equation number 1. Similarly, if we consider the second equation and assume that equation as some more constant mu or parameter mu, we get x as minus mu minus 10, y as minus 3 mu minus 1 and z as 4 mu plus 1. Okay, students, now we can say therefore coordinates of point on second line are x comma y comma z, which is minus mu minus 10, minus 3 mu minus 1, 4 mu plus 1. That is equation number 2. Now if two lines intersect, students, they will have one point in common, right? That means for some values of lambda and mu, the 2 points must match. Yeah, so let us go ahead and say if the lines intersect, then for some values of lambda and mu, the point on the first line matches with point on the second line. Alright, now on comparison of x, y, z values, we get therefore minus 10 lambda minus 1 equals to minus mu minus 10, and on simplification this gives mu minus 10 lambda is minus 9. Let us call this equation number 3. Okay, now similarly when we compare y coordinates, minus lambda minus 3 is minus 3 mu minus 1. This gives 3 mu minus lambda equals to 2. Let us call this equation number 4. And similarly on comparing z coordinates, we get minus 4 mu plus lambda is equal to minus 3. That is equation number 5. Now students, there are two variables lambda and mu, but we have three equations. Alright, now we say solving equations 3 and 4, we get lambda is 1 and mu is 1, but these values must satisfy the remaining one. So put lambda is 1 and mu is 1 in equation 5, that is this equation, and we get left hand side as minus 4 mu plus lambda, which is minus 4 plus 1, which is minus 3, which is same as right hand side, right? That means lambda mu 1 values satisfy the fifth equation, right? And therefore now we can say for lambda is 1 and mu is 1, points on the line match with each other. That means lines intersect. Alright, now students, we need the point of intersection, that is we put lambda 1 and mu 1 in 1, that gives point of intersection as xyz equals to minus 11, minus 4 and 5. Alright, let us go for second question. This says find the angle between the lines, the first Cartesian equation and second Cartesian equation. Okay, in solution, given lines we copy down. The given lines are x minus 1 upon 4 equals to y minus 3 upon 1 equals to z upon 8 and x minus 2 upon 2 equal to y plus 1 upon 2 equal to z minus 4 upon 1. Now students, if we compare them with the standard Cartesian form, we can get direction ratios. That is a1 is 4, b1 is 1, c1 is 8, a2 is 2, b2 is 2 and c2 is 1. Now once we have these values, we assume angle between lines as theta, and we know cos theta is mod of A1 A2 plus B1 B2 plus C1 C2, that becomes 4 into 2 plus 1 into 2 plus 8 into 1, and the denominator becomes square root of 16 plus 1 plus 64 into square root of 4 plus 4 plus 1. On simplification, we get, students, numerator as 8 plus 2 plus 8 and denominator as root 81 into root 9. This gives cos theta value as 18 upon 9 into 3, and this becomes on simplification 2 by 3, and therefore we can write theta as cos inverse of 2 upon 3. So here we get angle between two lines, right students? Cos inverse of 2 upon 3. Alright students, so here we complete problem solving on 3D lines. Thank you.
जल्दी